Let's look at another example of how you would use the second derivative test to find local minimum or maximums. My function here is x times e to the x. So I have a function of x times a function of x. Whenever that happens, we have to use the product rule to take the derivative. Think of that x as being your first function and e to the x as the second function. To use product rule, you copy and paste your first function, x, and multiply that with the derivative of the second function. Derivative of e to the x is e to the x. That's the first half of the product rule. Then you want to take the derivative of your first function, derivative of x is 1, and multiply that with this second function. So then f prime of x would just be equal to x e to the x plus e to the x. First, we need to set f prime of x equal to 0. Now we can take our f prime and set that equal to 0. Let's factor out the common term of e to the x first. That would leave us with an x plus 1 inside of the parentheses. Now that we have that factored, we can use the zero product property rule to set e to the x equal to 0 and also x plus 1 equal to 0. E to the x is positive for all values of x. Therefore, e to the x is never equal to 0. So there is no solution for e to the x equals 0. And then for x plus 1 equals 0, we can just subtract 1 from both sides, and that'll give us x equals negative 1. So x equals negative 1 is a critical point. We also need to consider when f prime of x fails. Therefore, this does not fail. Finally, we need to find f double prime of x and test f double prime of all of our critical points. Our derivative was x e to the x plus e to the x. When we find the derivative of x times e to the x, we're going to have to use the product rule again. Using the product rule, the derivative of x times e to the x, we would keep the first function the same, x, and then multiply that with the derivative of the second function. Derivative of e to the x is e to the x. Then we add that with the derivative of the first function, which is 1, times the second function, e to the x. And finally, we have a plus e to the x at the end. So our second derivative would equal x e to the x. And then we have 2 e to the x terms, so that can combine to be 2 e to the x. We only have one critical value to test, negative 1. Plugging in negative 1 to the second derivative, that would give us negative 1 e to the negative 1 plus 2e to the negative 1. That would simplify to negative e to the negative 1 plus 2e to the negative 1, which would be e to the negative 1. You can plug this in the calculator to see what it equals exactly, but basically this is a positive number. It's greater than 0. So now we have shown that f prime of negative 1 is equal to 0, and f double prime of negative 1 is greater than 0. Therefore, the graph of f is concave up at negative 1, and x equals negative 1 would be a local minimum.